probability of a complement of a situation. And remember what the complement of a probability is? It is the everything else that makes it sum to 1. So if the probability of an event is 1/4, the probability of its complement would be 3/4. So if I tell you the probability of me, I gotta write it down on my list of things to bring back. So I have a giant die that I normally have on my desk. If I tell you the probability of rolling a 1 is 1 out of 6, what's the probability of rolling a not 1? 5 out of 6, right? That's what a complement is. It's what comes together to make the entire 1, because we know that the probability of any event can range between 0 and 1, right? If the event is certain, right, that's the word we use for events with a probability of 1. So if the event is certain, so we could go ahead and remind ourselves a probability of 1 is what we call certain. And if the probability is 0, it is impossible.
Well, wouldn't that also be certain because it's certain to be impossible?
Yeah, I like that. That's good creative thinking. This is certain that it will occur, right? When we say certain for 1. So yeah, I mean, you could say that 0 is certain to not occur. I would agree with that. And then some really basic reminders. If P of A is greater than P of B, P of A is more likely. If P of A is equal to P of B, they're equally likely. Neither of them is more, right? So these equal situations is where we might have to say neither, like where our answer might be neither, because if neither of them is more likely, they're both equally likely. What are the two main types of probabilities that we talk about? Theoretical and experimental. So please go ahead and write that down. And we have to remember what those mean, right? How do we spell theoretical?
Sound it out. Yeah, that's what I mean.
I think it's that. You're good, bud.
That's what I mean. I'm not good at spelling.
What's the difference between those?
Theoretical is what it should be, or what it should be, not with testing.
Ooh. So another way to say theoretical, like what we didn't do a test, all we did was, yeah, but I underlined the T and the H.
Theorize.
All we did was think. Right? We didn't do anything. Theoretical probability, we think, and we say, okay, when I roll a die, the probability of getting a 3 is going to be 1 out of 6, right? We think. But then if I go to do it, that may not occur, right? I may not actually get this 1 out of 6 times. So experimental is when we actually do it, right? We run the experiment. We run trials. Whatever you want to put here. Run trials. Collect results. Depends. Depends on what you're trying to do. It also depends on what your intentions are. Do you want to present fair, unbiased information, or do you want to present biased information? And while I am a mathematician and have firm beliefs about like numbers being true versus numbers being manipulated, if you end up working in business and your job is to get this sale, you might manipulate the numbers a little bit. They're still true, but there might be like a little asterisk of like, well, what was the denominator we used, right? Who were the people that we surveyed who said 4 out of 5 dentists, right? Like that sort of stuff. It depends. Yes?
That reminds me, I found this so funny. There was a pizza, like, voted best pizza in Columbus. And then there's a little asterisk.
In 2012.
No, by family members.
Love it.
Love
Yeah.
that.
Yep, by our family and friends. The only people we surveyed were people that we like. Yeah, that'd be like if I was like, I was voted the best math teacher by my 1A class. Like, yeah, it's like, well, what was your survey? And that gets into sampling, right? That's a bit more statistics than it is probability. But statistics and probability, guys, are like very close cousins. Amar? Nobody in my 1A class likes me?
How would you know who you're going to?
Well, I don't know. I'm the first thing in the morning, and if I like gave them donuts and then I asked them, like, am I the best math teacher?
Okay, that's also biased.
What exactly? That's what I mean.
That's manipulating them to say.
Yeah, that's when you're like, hey, would you like a free cup of coffee? Also, will you fill out our survey? Like, yeah, you manipulate the numbers. All right, so try this. I want to make sure that we remember simple probability before we dive into the more complicated stuff. You should remember these things. It's okay if you don't. That's why I have a job. But this is stuff we've done in previous years, right? So if I roll a six-sided die for any of these three situations, we can calculate the theoretical probability, right? We are not actually rolling a six-sided die. We are imagining because, well, Mr. Hudson forgot to bring his die. So if we imagine rolling a six-sided die, what is the theoretical probability of rolling a 2? Oh, yeah, we have, and random.com has dies and everything else. Thank you, Alina. 1 out of 6. Careful now. Less than 4. So you would have to say less than 4. Yeah, because 1 works, 2 works, and 3 works. So reduced, it will come out to be 1/2. Probability of greater than a 6. There are 0 options for that. So that is certain to not happen. Amar? Yeah, you can. So the probability numerically, Amar, you would need to be able to say the probability is 0, but it's fine that you know that that means impossible. But like, if you were asked for a numerical answer, like you're not going to type the word impossible into comma, right? You're going to hit 0 and then move on. Make sense?
Yeah.
So yes, impossible's fine, but if you're asked for numerically, it's 0. So, guys, this is when, like, yes, you can chuckle at this, but we have to avoid copyright infringement. Back in the day, before, like, Apple Music and everything else, you've probably heard these horror stories from your parents. You would have to buy individual songs or albums, take them from the internet, put them on a device, and take them with you because the internet wasn't everywhere. Then, if you wanted to play life like a roulette wheel, you would just hit shuffle. And Apple decided, we're going to name one of our iPods the Shuffle, and all it's going to do, and my father-in-law has one of these, all it's going to do is hold music and play things randomly. No screen, no anything else. You just hit play and it randomly plays your music. So you better like the music that you put on it. So he uses it when he mows the grass and everything else. But so Greg has his knockoff shuffle called the Jumble. The Jumble randomly selects a song for the user to listen to. Greg has not bought very much music yet, has 6 classical songs, 7 rock songs, and 9 rap songs. Greg's in the car with his mom, though, and he really hopes that a not rap song comes, right? He's not supposed to listen to rap. So what's the probability that a not rap song comes up? What's his probability of being safe with his mom, or else, like, well, the other way, he might get in trouble? Katie Ann? 13, what'd you say? 22s? Yeah, 13, 20 seconds, if we want to say it like that. So, is that more than half, less than half, around half? More than half, so he's got a better chance of the song that he wants. So, like, the complement of that, what is his chance of a rap song coming on and his mom, like, reaching over and smacking him upside the head? 9 out of 22, right? So it's like, P. Diddy or Jay-Z or something comes on, his mom's like, what are you listening to? Oh, yeah, so I thought you were about to, like, not know who Jay-Z was, and I was going to be hurt. Try this on your own. Or situations. So this is an or situation. We're eventually, probably not today, going to talk about and situations. And is very different than or. Kayla? No, this says add. Maybe you just can't read my handwriting. Or, remember when I talked about where you sit in the classroom? Or means add. Or tells us to add things. So, the probability of blue or red really means take the probability of blue, add it with the probability of red. So, or tells us to add numbers, add probabilities. So if we want to break this problem apart, the probability of blue, 8 out of 21. The probability of red, also 8 out of 21. So their or probability together, 16 out of 21. I mean, there's one option to do something with it. Yeah, I'm going to just round to the third place. When I go to decimals, especially with probability, if it goes further than 3 places, normally it's safe to just cut off at 3. Well, round, right? Round accurately. So this was 0.7619. So the 19 made sense to just round it to a 2. Also made sense to just stop right there. Questions on the front. Those were our simple / theoretical reviews. Now on the back, with experimental, we actually do it, right? We run the experiments. We take the results that we have. So now the fraction that we're going to set up is all based off of results. So I'm going to make that reminder to myself. Based off of results. It doesn't matter what there was to start. Sometimes the results are weird. Sometimes we win the lottery twice. Like, sometimes probabilities not come true. Now the lottery, like the state lottery, the whatever, all of that utilizes... Have we ever heard about the law of large numbers? Okay, for a reminder for those of us that have forgotten, the law of large numbers says when allowed to happen over and over and over again and like continue to occur, probability will pan out to be at least close to true. But that's the law of large numbers, like a lot of trials. If we look at a small sample, it may not be true. It may not be accurate. So some of these things also don't really have predictiveness. Like, can we predict how many arm tattoos people are going to get versus something else? Well, I guess if we look at the experimental, I can't roll a die and predict arm tattoos. I do. My niece and my mom both had cancer at the same time, and that was my solution. Just go get a tattoo. I got one on my back too, but I don't show that one off at school because, well, it's on my back. It's an eagle, because I'm an Eagle Scout. So it's not like it's bad. It's a devil riding a Harley. No, it's an eagle. So, a devil riding a Harley. I don't have a motorcycle. I'm not a fan of the devil. I'm... Paulina, one of these days, you're going to come back and be like, remember how I was in 8th grade? I'm sorry. No, you actually make class a lot more fun, so it's all good. Keep doing what you're doing. 43 of these were arm tattoos out of a total 389. If we want to, based off that data, say the probability of the next tattoo being an arm tattoo, wait, not arm. Carefully read, not arm. So actually, I'm just going to write down both since I already wrote down P of arm. So an arm tattoo would be 43 out of 389. Oh no, but I got to do a little bit of math because the complement of it for not arm, like neck tattoo, head tattoo, those real sensible tattoo locations. I forget what stand-up comedian says a neck tattoo says I've gone as far in life as I would like to. Like, if you walk into a job interview with a tattoo across your neck, it just kind of says something about who you are. 389 minus 43. Yep, 346 over 389. Now, I bet you could also use that data in the chocolate chip ice cream situation. So I'm going to move on down to the dot plot to remind us how to work dot plots. And then we're going to talk about pizza, because why wouldn't we talk about pizza? The dot plot shows us how many pets each customer owned before entering Jeremy's pet store, right? They're taking a survey at the door. How many pets do you own right now? Each dot represents a customer, right? Like an answer from a person. Based off this data, what is a reasonable estimate of the probability that the next customer to enter Jeremy's pet store has exactly 3 pets? How many people had 3 pets? 3. How many people did they survey? Well, add them all up. 12? Yeah, those noises. No, I was not counting. I can't count and make noises like that at the same time. I was just making noises. Have I showed you the video of like how numbers came to be? With bongo, pongo, whatever. Yeah.
It's 13.
Wait, 13?
Yeah.
Uh-oh. 3 out of 13. Maybe somebody forgot a boop, and that's why they were off. Pat's Pizza made 21 cheese, 14 veggie, 23 pep, and 14 sausage pizzas yesterday. Based on this data, what's a reasonable estimate of the probability of the next pizza made is not cheese, right? That it needs some kind of toppings.
So all of those would have cheese on them, unless you're like a crazy person. They don't want pepperoni without cheese on the pizza. I would just like to say that that doesn't question does not make sense.
Yeah, but when you order pizza, are you like, I want a pepperoni? Like when you say pepperoni pizza, every
Pepperoni cheese. You always say pepperoni cheese.
yeah, the cheese is.
It's not actually insinuating, just by the way. If we want to use words accurate, you insinuate something when you take like somebody else's words and like. But a pizza person's not like insinuating that you want. They're inferring that you want cheese or assuming.
Yeah, when you say pizza, pizza has cheese on it.
I like how Alina's over here practicing her violin solo. Alina's like, you guys are talking about pizza. No, I can't. I don't know how to string instrument. Topped. Fine. What is the probability the next pizza is topped? It's not just a cheese pizza. It's not just a cheese pizza. What? What? Oh, that's reduced, right? Give me the unreduced first. 30 out of what? 30 out of 51. And then what'd you reduce by? Did you get the 21 and the 23 and the 14 and the...
That's not the right part.
How many pizzas got topped? Well, veggie, sausage, and pep. 28 plus 23 more, 40, 51.
Yeah, that's what I got.
So, Amar, hey, the side chatter, let's make sure that we bring Amar with us. Amar, this is the 14, 14, and 23. I think you just forgot part of this. That gets 51. But then, also adding in the cheese pizzas to get our total 72. Somebody verify, please, maybe?
Yeah.
Yes? Okay. So 51 out of 72. Still reducible by 3. I don't know what it is, though. 17? I think. 17 over 24? All you guys are weak, reaching for your calculator instead of just trying to do it in your head. I'm not anti-calculator. I just want to see you rise to the challenge. Amar? What? Okay. You should say it. You should say it.
Someone in 8th grade was using a calculator to solve 6 times 2.
I mean, gotta double check your work, I guess.
And she was using a calculator to solve 15 minus 13.
Look, hey, we're not gonna judge other people. Everyone's at a different place. Everyone's at a different place in their studies. All right, so the following frequency table summarizes the number of children that dads in dad's club. No, am I not allowed in dad's club? There's nobody with 0 children. I feel,
You're not dad.
but I make some sweet dad jokes. All right,
Dogs? You can count your dogs.
so I would have 4 then, I guess. But so number of dads over here, amount of kids they have. Based on this data, what is a reasonable estimate of the probability that the next dad to join dad's club has fewer than 3 children? So this is the group we're looking at. So really, this is the group we're looking at. How many have fewer than 3 children? You're good, Katie. 10.
Yes, that is the answer, but that's not what you did. Oh, my bad.
And we get 10 out of 20 or 1/2. Right? What was the argument out there?
No, that wasn't what you were asking. She just said 1/2.
I think that is what I was asking. Well, I mean, that's final answer. Yeah, she jumped over to get to the final answer. But yeah, 1/2, right? 1/2. And the bar graph. Making sure that we can read bar graphs still. Following bar graph summarizes the weather conditions in Crayon for each day of this month so far. Sunny, cloudy, rainy, snowy. Based on this data, what is a reasonable estimate of the probability that it is sunny tomorrow? How many sunny days were there?
Is it Ohio?
No, it's Crayon.
He said in Ohio.
I think they made up the city name, considering this word is crayon, like the thing that we color with. Unless that's like where Crayola is from.
You never know.
I mean, maybe Crayola renamed their town Crayonton.
If it's Ohio, you just forget the probability.
All right. So, sunny, 3 days. Total, 12, I think. So, probability of sunny. Or 1/4. Any questions from these notes? Oh, absolutely. Yeah, it's yours to take. Crayonton. Any questions? Yes. Okay.
Did you keep these right off the con? Because I think I've done every single one.
Yeah, I've done every single one.
Absolutely. That's what you get for doing your homework ahead of time.
Well, I mean,
Being bored in class.
it's super easy. We have nothing to do. No one's giving us any homework.
Easier
See,
than-
that's the opposite of the concern from the district. The concern from the district was don't overload kids as they come back because they haven't.
Friday don't give us anything, but you're not going to anyway.
Wait, he's not?
Hey, I'm okay
No,
with
no
that
one
because
does.
we don't have to work.
He would do that.
I give homework. I'm giving lots of homework.
Yeah, I thought you would. Miss Harper-
I like almost can't unless we move faster. There's almost like no more for me to give you.
I'll prove it that's my idea.
Hey guys, Chan has the jumble also. Look at this. Chan has the jumble also.
Good for him.
All right, so how we calculate expected value. Expected value is like what we are predicting based off whatever probability we've been given. So to calculate the expected value, we take the probability of the favorable event, so that probability of the event that we want, times how many total possible occurrences it has, which normally we're just saying is a number of trials, or a number of times. You can pull a hashtag in front of this if you want for number of trials. So sometimes we base expected probability off of experimental. Sometimes we base it off theoretical. Depends what we have to work with. So if we're using a random number generator, would we be safer to use theoretical or experimental results? Well, they should be like the same essentially. Oh yeah?
I just have to say that staying near close 1 out of 5 times every dinner party is very high.
I mean, depends on what kind of dinner party you're throwing,
Well, it includes barbecue sauce, so I think that's kind of reasonable.
right?
Maybe it's on the barbecue.
Maybe he needs an apron.
You eat it then. You just eat it. You just put it half.
No. It's a barbecue brawl. So you throw barbecue at each other.
A barbecue brawl?
Not necessarily. It might not stay. They have stainless barbecue. No, they don't. No, I don't know. Maybe they do. Harry might have stainless.
I'm going to use this video as an example of the attentiveness issues in middle school. Yeah, we weren't even looking at this for like 12 seconds before we got off task. So if Jose is using a random number generator, we're going to use theoretical probability. Okay, so theoretical probability, when we have numbers 1, 2, 3, or 4, each number has what chance of occurring? If we have the numbers 1, 2, 3, and 4. A fourth, right? Because we're only using 4 numbers. So, get something other than a 2. Guys, but we're not being asked for the probability here, right? Other than a 2 will be 3/4. But that's the probability. We don't want the probability. We want the number of times, right? So Jose will get something other than a 2. Well, 3/4 of the times, but we need to do that multiplication of how many times. Well, how many times does he run this? 500 total. So 3/4 of the 500. Well, you guys said 375. Questions on calculating that? All right, so try some on your own. Guys, if you bump on down to the comparing probabilities section, I did not include it in the picture, but neither is also an answer that is an option. it wanted to run off the page if I tried to make those pictures taller to show option C being neither. Now you decide to join us. I see how it is. Alright, so here's the notes from earlier. You can just have those. Except instead of like front back, it's 2 pages, right? But it is front back. And then honestly, you can have this one too if you want, or you can catch up and copy. We've barely written on. This is, so, Margaret, we're now on page 2. Don't feel like you have to catch up with us. But if you're wanting to, we did 2 different pages of notes. So there's page 2 of our notes. All you missed was me writing out this little thing up top. Is that to calculate expected value, we're going to take the probability that we have, whether it's theoretical or experimental, and multiply by the number of trials. So we came down to our first problem here and said the probability of getting something other than a 2 was 3/4. We're going to do that times however many times we have, and since he's going to do it 500 times, the expected amount of occurrences would be 375. I'm just trying to wait to give you guys a chance to try these on your own. That's if you've already done these, you're okay. I was also letting Margaret catch up and copy what she didn't have. You guys can talk with each other. It's fine.
Anyone else think the fact that they only adopted the chickens and cows and then the humans is kind of offensive? I mean, like, honestly, though, why not an Oscar? Honestly, if I was an alien, I wouldn't have done. I would only have done.
So you guys are already on the back, I'm guessing. All right, let's run through these real quick then. Jeremy is going to roll a fair 6-sided die. We sometimes also call this a number cube, by the way. Don't get thrown off if they say number cube. It's just a 6-sided die. 180 times. Thank you for volunteering, Katie Ann. How many times do we predict he will roll greater than a 4? 60? Yeah, so 60 times, right? Our answer is just 60 times. Because greater than a 4 would be 1/3 times our 180. We get 60. Chen has an MP3 player. That same jumble. People love it. Chen's jumble has a little bit more music. No? Okay. Oh yeah, he's just going to listen to 300, he has 360 songs. Okay. Yeah. Well, apparently he's just going to keep listening to the same things over and over again. Apparently. Well, thank you, Alina, for volunteering. How many classical songs do we predict Chen will listen to?
160.
How did we get that? 9 over 4? 4 over 9, right?
Oh, yeah, sorry.
You're good.
Chinese world right now.
Well, the problem is I'm ignorant and I don't know exactly what she means, and therefore I can't really comment on, like, she's probably right, I just don't understand what she's saying. How do you phrase it, like, verbally? I'm genuinely curious now.
So it's like, well, you say 9 over 4, but it's like,
So are you really saying 9 under 4? I'm seriously curious.
I
Like,
don't know. You just say it the way you say it.
interesting. It sounds like it's just one of those things where you know how to say it this way, you know how to say it that way. Like, is it just one of those weird cultural things, like, where I just might not, it might mess with my brain to try to understand it?
Yes, your brain will explode.
I don't know about explode. I've done a lot of things, thought about a lot of questions. My brain is yet to explode. I love card deck problems, so expect as we do probability that we're going to do more and more card deck problems. Ming is going to randomly draw 300 times out of the deck. Yo, I need you to write one thing down. This is also known as with replacement. If we forget that from last year, we talk about situations with replacement and without replacement, right? With replacement is when we reset things. We put things back every time. Without replacement gets a lot more complicated. Sorry, just being straight, it just gets a lot more complicated. So, Ming will draw something other than a heart. Well, what's the probability of other than a heart? Three-fourths, right? And then we're going to multiply that by how many times she does this. And we get 900 over 4, or what's that simplified to? Sorry, 75? Wait, what? That doesn't, I don't think that. Ah, so this is how many times she will get a heart, probably. So wait, other than a heart, we don't actually mean 75, because this says other than a heart. We actually mean 225, I think, right? So this is actually 225, because these are complementary situations. Guys, comparing probabilities is really just comparing fractions to decimals, or fractions to percents, or decimals to percents. So, the probability of Sandy flipping a coin twice and getting heads both times is 0.25, because half times a half. The probability of John Spinner stopping on the color red is 1/4. Which is more likely? Neither. There's always an option C on con. That is that they are equally likely. Yeah, I just did not cut it over. Harry and Larry cannot seem to keep their barbecue sauce in their bottles. Probability of Harry staining his shirt is 1/5, and the probability of Larry staining his shirt is 15%. What is 1/5 if you think about it in percent form? Yeah, 20%. So that's what our brain should really do, is convert this over to 20%. Which is more likely? Harry stains his shirt, Larry stains his shirt? Harry.
Because I'm having a barbecue brawl.
Barbecue brawl.
Larry
It's the ballroom blitz. Okay, you have to actually research this. I disbelieve you that there is, I don't know if that's a word, that there is stainless barbecue sauce. It's like made to be able to food fight.
Oh, I have no idea.
Oh, okay.
I was just making stuff up.
Well, that's what I normally do, but you guys think I'm like